string of negligible mass going over a clamp pulley of mass m support a block of mass m as shown in the figure. The force on the pulley by the clamp is given by. Okay, fine. Now look here carefully. We are going to utilize this particular word here, negligible mass. Okay. Now, you might have been told in theory classes that while drawing the free body diagram, it is very much essential to, or it depends on what system you are going to choose as your body. Okay. So there are two options here. Okay. There are two options here. First option is just to choose pulley itself. And the second option is to choose pulley and the portion of the massless string in contact with pulley. Okay. Now that negligible mass thing is at work. So if we ignore the mass of the string, okay, if we ignore the mass of the string, then for the second case, okay, then for the second case, if this is my pulley, then look here, it is an equilibrium. Now look, the string portion which is in contact with the pulley, the first quarter that much, okay. If we consider this as our system, then it is an equilibrium under the influence of which forces? Tension here, tension here, okay, and we should also not ignore the pulley's mass, small mg here, and then see, they want us to find the magnitude, okay, so we can consider them as the reactions here. Let's call this as Rx and let us call this as Ry. Yes, it's option D. Okay, it's option D. Now see, summation fx equal to 0. Okay, summation fx equal to 0 gives me what? It gives me Rx equal to negative T or sorry, Rx plus T equal to 0. Rx minus T, sorry, Rx is to the right, so positive, minus T equal to 0 or Rx equals T. And what about summation Fy equal to 0? Summation Fy equal to 0 gives me Ry minus T minus Mg equal to 0. So what is Ry? Capital T plus Mg. But what is capital T now? Capital T is essentially nothing but the weight of this hanging or suspended mass, isn't it? So put it there. So Rx is equal to capital Mg and Ry equals capital Mg plus small mg. Okay, so these are, this is like Rx I cap plus Ry j cap, so its magnitude will be root of Rx squared plus Ry squared, take g common, capital M squared plus capital M plus small m dot squared. Is that clear?
Yes, sir.
Now see, what happens if we just consider the pulley as our system? Okay, two options for FBD choice. If we just choose the pulley, okay, if we just choose the pulley, then how do things work? We essentially arrive at the same result, but if we consider the pulley itself, then we will show its weight. We will show the horizontal and vertical components of the reaction. Okay, we will show weight and horizontal and vertical components of the reaction. But now we have to consider a distributive load. Okay, because a string makes linear contact. string makes linear contact and not point contact with pulley. Okay, that is important. Now that is actually something which may create some confusion in your head. Like if at every point here there is some force acting on the pulley by the string, how are we going to incorporate those forces in our calculations? Isn't it? If that is the question that stuck you, then the solution to that is, see, the string is in equilibrium. All of us know that. The string is in equilibrium. Okay, if the string is in equilibrium, then any portion of it will also be in equilibrium. Do you understand this?
Yes.
Okay, so just take into consideration that quarter. Okay, that quarter. So if that string is in equilibrium, that string with the pulley should also be equilibrium, and anyways we are going to ignore the mass. Okay. So even if we consider this distributive load, even if we consider the distributive load here, we can say it gets transmitted to the pulley. Okay. As everything is in equilibrium, this distributive load gets transferred to pulley. Okay, gets transferred to pulley, and that transfer is what we have shown here, because the tension is not really acting a directly acting force on the pulley. Tension is in the string, correct? But because that portion be considered to be in equilibrium, we consider our string to be pulley but portion of the massless string to be the value of reactive forces, or the force that the clamp exerts on the pulley. Is that clear?
Yes, sir.
Yeah, so keep that in mind. Fine, let's go to question 6 now. Okay, see now, because it doesn't make any point contact with the pulley, it makes more and more difficult to actually come up with the net effect that distributed load will have. But we have actually answered it indirectly, saying that the string will be also in equilibrium.